Hello everybody. So in this video we're going to look at Simpson's rule, and this is a numerical integration method used to approximate the definite integral of a function. It is based on approximating the curve with a series of parabolic segments, and Simpson's rule is generally more accurate than the trapezoidal rule. So if we look at example 1, we've been given this curve, let's say this is f of x, and we've broken it up into two strips when it's centered on the y-axis. We've been asked to show that the approximate area under the curve is given by this formula, and this formula is Simpson's rule when we have two strips. So we're going to prove this. So the first thing we need to do is, it says here it is based on approximating a curve with a series of parabolic segments. So we need to think that the function of x is a parabola. Well, as a general form, this would be ax squared plus bx plus c. So what we want to do then is to work out the area by integrating underneath this curve, by integrating ax squared plus bx plus c between the limits of negative h and positive h. So this is a fairly simple integral to work out, and we're integrating it with respect to x. So this becomes the area is a third, or a over 3 x to the 3 plus b over 2 x squared plus c multiplied by x, and the limits between negative h and h. So now to work out the area, we can substitute in our limits. We'll begin by substituting in this h. So the area will be equal to a over 3 times x cubed, or h cubed, plus b over 2 h squared plus c times h, minus our lower limit, and when we cube the negative h, it becomes negative a over 3 h cubed, plus when we square the negative h, we get a positive, so plus b over 2 h squared, and then c times x, c times h, or negative ch. Okay? And we can tidy this up by multiplying out by this negative. And when we do multiply it by the negative, we have it like terms. We have the area will be a over 3h cubed plus another a over 3h cubed. So 2a over 3h cubed. This positive b over 2h squared will cancel with this negative b over 2h squared. So these will cancel. And this ch will add with this positive ch. So we'll have 2ch. Okay? But what we want to do now is we want to work out this area in terms of our y values. So if we look at y1, well, y1 we can find using this x value, negative h. And we've been given the function, so we can substitute negative h into this, and we get a times negative h squared, so h squared. Then we have b times negative h, so negative bh, plus the c. And then for y2, well, y2 is centered on 0, so the ax squared will cancel and the bx will cancel, and this will be equal to c. And y3, well, h is now positive, so we get a times h squared plus bh plus c. So ah squared plus bh plus c. Like I said a minute ago, our aim is to write this area in terms of these y values. The problem is we have an h cubed term here, and we have no h cubed terms in our y values. We've also got a division of 3. So what we're going to do is we're going to factor out the h and the third. So the area we can write as h over 3 lots of 2ah squared plus 6c. Now we need to have a 6c because we've divided this by 3. So we factored out that third. So now we need to create this expression using our y values. So if we begin by substituting in y1, so we have ah squared minus bh plus c, and then we'll substitute in y3, so another ah squared, this time positive bh plus c. Well, then you can see this ah squared will add with this ah squared to give us a 2ah squared. This negative bh will cancel with this positive bh, and this c and this c will give us 2c. What we need is 6c. So we need to add on another 4c's. But this 4c's we can have by multiplying this y2 by 4. So this becomes the area will be h over 3 multiplied by y1 plus 4y2 plus y3. And this is Simpson's rule for 2 strips. Okay, in example 2, I'm going to show you how to use this to approximate the area under a curve. Okay, so because we're using more strips now, we've had to adapt our formula. So we've got h over 3, where h is the width of the strip, y0 is the first y value, yn is the last y value, and this is multiplied by 4 lots of the odd y's plus 2 lots of the even y's. This will make more sense as we work through this example. So we've been asked to use Simpson's rule with 4 intervals to estimate this integral between 2 and 10. So the first thing I need to do is to identify my h, and this is the width of each strip. So in this case, h is equal to 2. So now we can say that the integral will be approximately 2 over 3, substituting this h in for 2, multiplied by y0, which is our first y value, so I'll call this y0, plus yn, well, this will be our final y value, so y4, plus 4 lots of the odd numbered y's, we'll call this y1 and y3, and then plus 2 lots of our even numbered y's, which we'll call this one y2. And then we'll close that bracket. So now we need to work out the y values. So if x is going to be 2, then y0, our first y value, we can work this out over here. So y0 will be 2 times the natural log of 2 over 2. These will cancel, so this will give us 0.693. When x is 4, y1 will be 2 times the natural log of 4 over 4. And again, this is 0.693. When x is 6, we'll get the y2 value. So 2 times the natural log of 6 over 6, which is 0.597. When x is 8, we get our y3. And this gives us 0.520. When x is 10, we get y4. And this is 0.461. So now we can substitute these y values into here. I'll just block this off. So we get the area will be approximately 2/3 lots of YR 0.693 plus 0.461 plus 4 lots of Y1, so again 0.693 plus Y3 0.520 plus 2 lots of our even Y's, so 0.597. Then we'll close that bracket. And when we work this out on our calculator, we get the area is approximately 24/5 units squared. Okay? Well, thank you very much for watching, and I hope you found that useful. If you did find that helpful, please like and subscribe. And you can download the full lesson and worksheet from our website, mrmathematics.com. There's a link in the description below. Thanks again, and take care.